Good morning, colleagues. Today we are going to solve exercise 3.23 from the book Fundamentals of Electrical Circuits. In this exercise we are asked to determine the sub-zero voltage of the circuit by applying node analysis. Well, first we are going to draw the directions of the currents by doing a visual analysis of the sources it has, and then we are going to do the equations. First thing I look at is this 30-volt source. The polarity is up, so I assume the current is coming in this direction A. Right now we name the currents. The current enters through this resistance and reaches this point. If I look at this source, 3 amps also comes here and reaches this point. At this point it has to find its way somewhere. The first thing that comes to mind is down. The current comes this way and the other part goes that way. How can we observe A? I put this current towards there because this source of a dependent source tells me that the polarity is to the left, therefore it also exerts a force towards the left side. This current that comes from here meets this one that comes from here. The two join together and I suppose the path it takes is downwards. And let's note that the polarity is 0. Here it tells me that the dependent source depends twice. A, the zero voltage and the sub-zero voltage market for us here. Let's observe that the polarity is plus minus, which tells me that the current enters from above, right? So the marking of the currents turn out well for us. A, this node that is here, this point is the same, it is 0, right? And this part has reference to what must be the common land. Now, this point here, I'm going to give it a name. I'm going to call it V1 to do the subsequent node analysis. So I'm going to start at node 0. 1 twice the E. The currents entering will be equal to the currents leaving according to the Kirchhoff current law. So in this node this. Well, let's give names to the currents now. If I'm going to call this current I1, I'm going to call this current 2, this one I'm going to call current I3, and this one I'm going to call the current I4. So the current then, Let's observe that in this node V sub 0, where we are going to do the analysis, the currents that exist between I1 and I3, the current I1 plus the current I3 will be equal to what comes out of that point, that the current I2. Well, then the current 1, the current I1, we observed that it has this direction, or that right was the one we put in it. Does it mean that the voltage of 30 volts is greater than V sub 00 in the direction of the current? So it would be 30 to 0 over a domain. By Ohm's law, there is no voltage, there is resistance. That gives us the current N plus the current I3, the current I3. We observe that it goes to the left. We have to. We call this point V1 and this point as a node. Here there is a voltage and it exerts it to the left by the current I3. If the current I3, the versus 1 exerts a force to the left, but also a dependent source that adds to the V1 that also goes to the left, and the V sub 0 due to the opposite voltage would be in the opposite direction. So the I3 is the voltage V1A, the dependent source, which is twice the V sub 0. I'm going to mark it right. Minus a 0 because this is the one that opposes all this about. E4 minus 4 min. All this current I3. That's going to be equal to the current I2. The current I2 will be the node V sub 0. About 2 min. Okay. So if I start separating, I have to 30 over 1. Well, it would be 30. But I'm not going to put it over 1 minus V sub 0. About 1 V sub 0 plus E. Well, I'm going to draw down here. Better. Here. 30 minus 3 sub 0. Plus V1 over 4 plus 2 times 0. Over 4. Minus sub 0 over 4 in. Equal to V sub 0. Over 2. Well, hey, I already have these equations. Now I'm going to leave everything that has variables equal to one side and everything that has equals to the other side. So I'm going to put it here. V1 out of 4e. Well, let's do the following. Everything that has V1, well, this would be V1 over 4 if the only V1 that we see here, and we are going to add everything that has V0, that would be minus V0. Plus 2/4 or a half of V0 minus VV minus 1/4 of V0. If I add all that, it will give me minus 5/4. From V0, all of that will be equal to 30. On the other side it will be minus 30. I can multiply by 4 on both sides of the equal, and multiplying by 4 on both sides of the equal will give me. The first equation would be V1 and minus 5 times 0 equals minus 120. This is my number 1 equation. Okay. Okay, now I have the equation. I'm going to work. I'm going to delete this with node V1. I'm going to put node V1. Let's work here. On node V1. We are going to observe that at that point the current enters 3 amperes. Enter here and grab 2 paths, the N3 and the N4. Then 1 and 3. Plus N4 is going to be equal to 3 amperes. But the interesting thing is that it is equal to well and 3 equals a V1 plus, because we already had it in the previous equation. You can rewind the video. We have that versus 1 plus the tension 2 times 0 minus times 0 over 4 would be versus 1 plus 2 versus sub 0 minus versus sub 0. Well, over 4 plus the current and 4 and the current and 4 volts 1 over 16. Hey, the current that comes this way, the voltage across the resistor, is then equal to 3 amperes. Separate the variable. I'm going to get that V1 over 4 plus 0 over 4 plus V1 over 4. Here it would be 2 times 0 minus 1. It would be V sub 0 over 4 plus V1 over 16. All of this equals 3 amps. I'm going to multiply by 16. Hey? Well, first let's wait for what V1 has. If I add this with this, I'm going to get that it would be 5 over 16 V1 to V sub 0 over 4 equals 3. If I multiply it by 16, I'm going to have to. Here I have 5 volts 1 more, Well, it would be 4 V sub 0 equals 3 times 16 would be 48. That would be my second equation. OK. Now to solve it you can use any method. Hey, Kramer? Substitution. Equalization, reduction. Hey, Jordan. Or a calculator or MATLAB. Personally, I like to use MATLAB and I'm going to delete this for you. I'm going to delete matrix A as 1 minus 5 1 minus 5 1 space minus 5 semicolon to move to the other row 5 4. Five is step 4. Now the matrix V, the one on the other side of the equal, would be minus 120 and 48 to 120 semicolon and 48. Now the solution variable is going to be equal to control plus V. So that gives me a minus 8.27 and 22.34 or V1. It's equal to minus 8.27 volts and U. C0 is equal to 22.34 volts. Ready. Then they asked us to find 0 and V sub 0 is 22.34 volt. Well, see you in the next exercise.